Well, good afternoon, everybody. My name is Rob Berridge. I'm one of the directors of Heat Engineer Software Limited. I'm recording this on Friday the 10th of April, Good Friday, in this what can only be described as very, very strange times for all of us in the world at the moment. And I was asked by a few people to possibly do a video on a presentation that I generally give when I go out to shows, etc., on discussing the importance of heat loss calculations and why the industry, I think, is so far behind, certainly within the UK system. So I'm going to be playing around with some different slides for you and go through some set pieces that I talk about. So if I open up this this PowerPoint and just go from this slideshow that I've got. So the bottom line is that I think we have quite a big problem in the UK in the sense of plant sizing, in pipework sizing, in our build quality, all sorts of things that have caused some pretty major required needs, if you like, within the industry to try and shake it up and get some accountability, and that's something that I've been pushing for a few years now to try and get that understanding, and hopefully this will kind of demonstrate the need for this. So this is me. I've been in the industry now for about 36 years, both as a domestic and commercial engineer, gas engineer actually. And teamed up with my partners Rich and Ben to create this new software tool, Heat Engineer. The kind of sort of things I do, I work in plant rooms like this, and this is where I really wanted to start to talk about the understanding of plant rooms and domestic installations, etc., etc. This particular project here is something that the management company asked me to go in as an independent consultant and just comment on what was going on. This particular cascade here is actually 5.4 megawatts, so 5,400 kilowatts that is running this. Now this is feeding, I think it's about 130 flats, so they're quite small flats. Now, if you just, I'll do that with on my calculator right in front of me, of me now. And if I just type in 5,400 and I divide that by 135 properties, that's basically giving us 40 kilowatts. If everybody wants to play with their calculators, you can see that's 40 kilowatts per small 2-bedroom property. And we all know that they won't all be using that 40 kilowatts at the same time, etc., etc. So we can see that this is massively, massively oversized. Now, people talk about diversity values and all the rest of it, etc., etc. But what actually is needed to get boilers into their sweet spot and to get them running at a nice low modulation rate with a nice low flow temperature, as we all now understand is what is required within systems, we need to size systems correctly. We don't want oversizing. We'll come on to oversizing in a second. The actual figure that was required for this unit, including the hot water and a diversity factor in it, was actually 2.3 megawatts. So you can just imagine what the savings would be just on plant costs alone of upgrading scenarios like this. Not that these need upgrading, but that's the point, and this is where you can save clients vast sums of money. So basically, very few projects are calculated for heat loss. People don't do measurements; they don't get their scale rule out, as you can see there, and actually calculate out room by room calculations. And this has led to what can only be described as rule of thumb or guesswork within the industry, and it's caused some quite big issues, certainly on efficiencies, and I'll come on to efficiencies shortly. This is where it starts to get quite interesting. So we could see that last project, there was 135 flats there. They worked out at 40 kilowatts per unit, and that's what was being supplied by the boilers. This is it. This is the facts. The best-selling boiler in the UK is a 30 kilowatt unit. Now I know everybody's going to say yes, but that's designed on hot water, which is absolutely fine. and I understand that. And I think what we'll do is at the end of this particular PowerPoint, I'll come on and I'll demonstrate with the excellent High Tools app as to why I think 30 kilowatts through a combination boiler for the hot water side is about the maximum you should ever go to. But you still, the problem being is that with range rating boilers for a 2-bedroom flat that's probably got 3 or 4 radiators and a total output of, not even 3 kilowatts, something along those lines possibly, that is going to be very difficult to get the boilers running in their sweet spot, because there are very few boilers that can modulate down to those kind of levels, as most people that understand what I've been trying to do can see. Best-selling heat source pump in the UK is a 10 kilowatt unit, and yet they both heat the same space. So this is something that I've been again trying to kind of get manufacturers to get on board, and see if there's a possibility that we could start to get smaller boilers and gas boilers, etc., into the market and save an industry that frankly is just wasting an awful lot of energy. So this is the back of my house. It's a 3-bed Victorian mid-terraced, 1905. I think I kind of hinted earlier on that kilowatt outputs for flats are going to be very low. But if anybody wants to hazard a guess on what this property does, I'll just think up in your head. You imagine as an installer, you're going into that property. So 3-bedroom mid-terrace Victorian property. It's got no heating in it at the moment, we'll imagine. So if you're going in there, what would you be quoting to your clients to put in, to install into that property? Now, I've had everything from 30 to 40 kilowatt, all sorts of things that have gone in there, but we'll have a look and see. So to guess that, I've changed the windows, I've put some insulation in the loft. You can probably just about see, if I move my mouse over here, you can just see up here, there's the side of a Velux window there. So I've actually installed, I created a loft room up there, which I built, and so it's essentially a 2 up, 2 down with a converted loft area as a loft room. So you can see that. So there's a few improvements that have been done on there, but to guess the heat loss on that. Now you've all got these in your mind. I can't do live situations here now, but this next slide actually shocks quite a few people. That's the actual heat loss, and that's the calculated heat loss for my house. Now the problem is, at the moment you can't buy a boiler small enough to match that. Now that heat loss calculation is based on a London outside mean temperature. I'm in North London in Rickmansworth, an outside mean temperature of -1.8. Now I do some training on this, on heat loss calculations, of how to do it longhand. So please get in contact through our website if you'd like to get involved with some of that. We'll be bringing dates shortly once this virus lockdown is lifted for us. So that's quite surprising to an awful lot of people. There are modulation boilers on the market which will modulate down lower than that. Typically the new Viessmann, I think, runs down to about 1.7 or 1.9 kilowatt. But that's 4.76 kilowatts at -1.8 outside, and you have to ask yourself the question: how often is it at 1.8 degrees centigrade outside? And it's probably only about 2 or 3 weeks of the year, if that. So the majority of the heating season that you're using is probably 10, 11 or even 12 degrees outside, and you're just heating up. So we wouldn't need anywhere near 4.76 kilowatts. And this is why I'm asking manufacturers to actually start thinking about the understanding of bringing in much smaller output boilers, or creating modulation ratios that are wider so you can get a much lower output. I've argued for a long time that we need modulation ratios down into watts. So, like if you can get a boiler that would run down at 500 watts, even whether a burner can be designed and built to run down at 500 watts, would probably be a challenge. But that's kind of what we need if we want to really start to see the efficiencies. So these are the facts. The average house heat requirement for UK properties is between 6 and 8 kilowatts. Not, as we've been kind of led to believe by wrong calculations in the past, of anything up to 20, 30, 40 kilowatts, or even future-proofing buildings by putting in a 40 kilowatt. I mean, unless you are literally building a hotel, or a small castle, as we all know, the Heating Academy, Kim Betty states, you just don't need those kind of outputs. And so this is what I think is very important to highlight and get the real facts out there and bust these myths that big boilers are needed. They're not. It's as simple as that. So what are the problems with oversizing? Well, I think we can all agree that if you imagine sitting in front of a light switch in your property and turning it on off all day long, that light switch is not going to last very long. And that is the same thing with boilers and, in fact, all heat source plant. If you oversize, you will get boiler or heat source cycling. Not something that any of us really want to do. We can design systems that limit the cycling. In other words, we can spread out that cycle time, because I think all boilers will cycle to a certain degree once they get up to temperature and you've met set point. But what we want to do is try and limit that, because you get a surge of power every time a boiler fires up. Most boilers will fire up on a minimum rate of maybe 5, 6, 7 kilowatts in order to get the burner to run, and then they would modulate down. Now, if that's doing that every 30 seconds or a minute or something like that, you can start to quantify and see the problem. And with modern houses now getting better insulated, etc., even though they're not brilliantly, and I'll come on to that again in a minute, but you can see the problem. I mean, this is what I think boiler cycling looks like. I mean, does that really look like it's running efficiently? Think of a great big heavy truck like you can see there, stop start on a motorway. It's using gallons and gallons of diesel and fuel and pumping out particulate matter and all sorts of emissions, and it's not getting anywhere. So you're probably getting, out of a car or a truck or something like a car. Let's just take a car for argument's sake. You're probably getting in traffic like that, possibly 20 miles to the gallon or something along those lines. Whereas if you were, using my mouse again, if you were over this side of there and you were running at a steady 60 miles an hour or something, as the factory efficiencies state in car manufacturers, you'd be getting close to 60 miles per gallon. So we can again see the problem. And this is what happens with boiler cycling. So essentially, with not calculating correctly and not sizing the plant correctly, you are actually selling your clients short, because you are making their systems inefficient and costing them unnecessary money to run their heating systems. And that can't be right for anybody. So we are bombarded in the UK in media and all sorts that we have a huge energy crisis. Well, again, those that have known me and those that understand what I try and do on social media is I state that we don't have this. My point is this: that is an energy crisis, and that's an energy crisis which most of our UK homes actually suffer with, which is lack of insulation. Simple as that. That poor fellow is struggling with it, isn't he? So this is what I've been saying. This is what I've been saying for a long time now, and this is what I think that is more akin to the truth, and that is we don't have an energy crisis. We have a wastage crisis. We waste fuel crazily. I mean, it is literally like grabbing a wad of cash, going out into your back garden and throwing it into the air, because that is exactly what you're doing. Sorry, what we are doing. Getting onto buildings, and this is something that, again, is very close to my heart. Been in this industry for a long time, built many properties and renovated, many more. Performance testing on buildings, or performance testing on heating systems, or performance testing on frankly, anything. That's a 10 quid toaster there. And it's something that, again, I pull up. And there's a £500,000 house. I think it's actually Harry Potter's house, if anybody looks quite close. But if you think about the testing on these projects, on these products that we have and we're sold, this house is the biggest purchase that anybody would ever make in their lives, and yet we probably spend more time choosing a bottle of wine than we do actually spend time looking around our houses that we're going to buy brand new, because we wrongly, in my opinion, trust the narrative on how well they're built and how well they're tested. And the simple facts are this: there's more performance testing on a £10 toaster than there is on a £500,000 house. I mean, surely that cannot be right in 2020. And this is a fairly recent thermal image of a property, a new build property, and that's the kind of heat loss that you're seeing through that building. Anybody that's not done heat loss, you can see that these purple bits are cooler than these other bits. This is quite warm in comparison. So the face of this wall, you can see the roof looks like it's fairly well insulated, but there's issues on the walls here. Okay, and that's what we're getting in the, because there isn't the performance testing. Now, what we have in the UK is building regulations and what are called air change rates of up to 10 air changes per hour. Now, that is a very, very poor build if that is the case, and I don't think it would really be allowed, even though it's up to 10 air changes now. Most are down to sort of 5 and under. Now, if anybody's heard about MVHR, which is mechanical heat and ventilation recovery, I think this is a very, very big thing, and one good thing that installers should definitely get themselves involved in. The training doesn't take that long to learn, and the calculations don't take that long to do, but you can save an absolute fortune on the heating bills for clients. The only caveat to that is that you need to get to a minimum air change rate of about 4 or less. Now, if I go back to the 10 air changes per hour, let's just do a basic calculation. If you've got a 2-bedroom flat, and we'll call it 100 square meters of space, that's quite a big 2-bedroom flat, normally about 80, aren't they? 60 to 80. But if we've got 100 square meters of flat, we've got a 2.4 meter high ceiling as standard. So that's 240 cubic meters in that property. Now, if we are saying that we can have an air change rate of 10, that means that that building can leak up to 10 times that. So 240 cubic meters times 10 is 2,400 cubic meters that building can leak every hour, and it will still pass building regulations. Now, you have to ask yourself, is that acceptable in 2020? I would argue that absolutely it is not. So what do? We are now tasked, government have signed into law that we need to get to net zero by, I think it's 2050, isn't it? Sorry, 2050. But by 2025, there will be no new fossil fuels being allowed to be put into new builds, and we need to try and get some accountability into building regulations and stop the energy waste, which we just covered. So in order to do this, we need to quantify the heat loss of the existing UK building stock and find out how much energy these places are leaking. And so we've developed this software in order to do that. Now, the beauty about that is that you can do an existing project of, it might have single glazed windows, it might have, poor insulation in the roof spaces and walls, cavity insulation, that kind of thing. We can go around, do the calculations based on those. We can then offer to our clients upgraded windows, upgraded insulation, etc., etc., and we can enter that into our software, give running costs, and actually show the difference between what they actually have existing and what they could potentially have if they do certain bits of insulation. And that is completely customizable, and you can change that as many times as you would want. So the bottom line is that we need to build better, we need to calculate the heat requirement, performance test, which is the most important thing in my understanding, and we will save pounds and we'll all breathe better. In fact, just to bring into that breathe better statement there, MVHR has been proven. I mean, up to building regulations now. I mean, you have trickle vents in windows, you have all sorts of extraction fans, etc., etc., which lose heat. But of course, if we make our buildings so airtight that they can't breathe, then what do we get? And we see it on a lot of new build projects now where there's mold growth, the air quality is not very good, and more importantly, equally importantly, we see children and sufferers of asthma having real bad asthma attacks purely because of the air quality within these properties. Now, MVHR with decent filtrations in, I think they're called F3 and G4 filters, if you have these installed into your property, which are not a lot of money, they can save a fortune in running costs, and they will completely change the air change rates as well. Our software does calculate that. But it's been proven that sufferers of asthma, etc., do improve massively with having that air quality maintained. So a very, very important thing, I think, and something that we should all be thinking about in the future. So thanks for listening to this. I'm just going to show you, I'm going to move on quickly and go on to the HiTools app as I stated. And I just wanted to just prove a point about velocities in pipework, something that I think we all need to understand. So if I just get rid of this PowerPoint here, back to that point there, and I will bring up the HiTools app. Now, this is a superb bit of kit for calculating out. Once you've done one of our heat loss calculations, for argument's sake, you will have a room by room heat loss of what you need. But we'll start needing to then start doing pipework sizing, etc., etc. Now, I'm not going to run through the whole full calculation, but your average combination boiler, for obviously, we talked about hot water speeds, didn't we? Your average combination boiler generally works on about a 35-degree temperature rise. Now, I'm just going to do this. I'm not going to go right into detail about the calculation process and specific heat capacity of water, but if I just put in a 30 kilowatt boiler, as we said, I'm just going to do the calculation as we speak. So it's 30 kilowatts divided by, and inside parenthesis, 4.19, which is the specific heat capacity of water, and then times, as we said, a 35-degree temperature rise. So do that 35-degree temperature rise, close your parenthesis, and equals. And that equals 0.204 litres per second. So 0.204 litres per second. If you want minutes, obviously you times that by 60. So 0.205, so it's 0.205 we'll say. So on the Excellent HiTools app, if you go onto their homepage, which is here, and you click right down at the bottom here, which you can just see there, if you click on pipes, we want to find out the 0.205 litres per second, and as you can see, I've set this now to litres per second. So if we clear that up here and we put in 0.205 litres per second and we click done, we now just need to start discussing water velocities. Now, velocities in pipework, and this is something very, very interesting, and if you can just see here that this is the meters per second of velocity. This is something that's really quite important that people need to understand. Now, the CIBSE guide does state that mains water can run up to 3 meters per second, but it's well documented and well proven that systems or pipework and components, etc., will start to erode when velocities are over 1.5 meters per second. So I would always try and size on that size. You will, and everybody's noticed it. If your flow rate is too high on a combination boiler, you'll get system noise. You'll get clonking when you turn the taps on and off, water hammer, that kind of thing. So you put in a shock arrestor, etc., those kind of things. But looking at the pipe size, and every single combination boiler we know has a 15 millimeter inlet and outlet. Now that's not full bore right the way through the boiler itself. The heat exchanger, the plated heat exchangers, or that they will be sized to the kilowatt rating of that boiler, and the flow and kilowatt are intrinsically linked. They're joined at the hip. But if we were to say 1.5 meters per second for argument's sake, if we look down that right hand column there, you can see that meters per second, as we just showed there, that velocity. If you look at 15 millimeter pipework there, it's 1.41. That's pretty much bang on to 1.5 meters per second, isn't it? So you can imagine that. Now you can go into all of the pressure losses across that. I mean, that's actually got 158 millimeters per meter of linear pressure drop on that, which we won't go into here. That's something that I would recommend everybody goes onto the Heating Academy in Northampton training days, and that Kim will go into much more detail about that, what that actually means. But what I'm saying is that so that's a 30 kilowatt boiler. So based on a 30 kilowatt boiler at 15 millimeter pipe. I don't believe that anything should ever go anything higher than that, and that's why I think a 30 kilowatt boiler, combination boiler should be the maximum one that's ever really installed into a property. So I hope that this video has helped a little bit of understanding, please give some feedback. Always interested in that, and keep the debate going, which is the most important thing. Thanks very much. Bye bye.